All right. Well, hello all, and thank you for attending this Coastal Beach Water Quality Work Group meeting. A quick heads up, this meeting is being recorded for State Water Board records, and it'll be posted to our work group webpage after. For those who don't know me, I'm Michelle Robbins. I'm an environmental scientist here at the State Water Resources Control Board, and I'm within the Ocean Standards Unit here. I'm also the program manager for the Coastal Beach Safety Monitoring Program. As we go through this meeting, please feel free to use the icons pane to raise your hand if you have any questions, or you can type those questions in the chat and I will get to them as soon as possible. This is our first meeting of the year, and as you may know, these are held biannually, so we hope to have another one sometime in November, and the information will go up on our webpage at least 10 days beforehand, so keep an eye out for the save the date emails from our email subscription lists and on that webpage. So as you guys might have seen, we have a pretty packed agenda, so we're going to roll right into introductions and updates, and then I'll share a little bit of information before we kick off our presentations. I'm going to call each of the local agencies first, and then ask for those joining from other organizations at the end. So please give your name, affiliation, and if you have any updates you'd like to share with the group. And we're going to start with the East Bay Parks.
Hello, can you hear me?
Yes.
Hello, can you hear me? This is Hal McLean, East Bay Regional Park District. Yeah, we do water quality at Crown Beach and Keller Beach. And actually, we did have an SSO in February at Crown Beach. And we also see a lot more exceedances than normal this year at Crown Beach, and fewer exceedances than normal at Keller Beach. Also, I think Sabrina's on the line here as well.
Yeah.
Hi, I'm Sabrina Sexton, East Bay Regional Park District. I work under Hal, and he gave all the best updates.
Thank you. Humboldt. Do we have anyone from Humboldt County here today? Okay, moving along, Long Beach. No one from Long Beach? Oh, perfect. Los Angeles.
Hi, I'm Vardui Hovsepian. I'm with LA County. I'm new to the program, and we have a few others from our county.
Awesome. Hi, Vardui.
Good morning.
Good morning, everybody. Go ahead, Ashley.
Hi, this is Ashley Duong from LA County. I am the section chief of recreational waters programs. And no updates. This is my first time. I'm glad to join. Lucy, go ahead.
Thank you. I'm Lucy Makitarian. I'm with the LA County Environmental Health Department of Public Health, and I am Environmental Health Services Manager over the Recreational Waters Program. This is my first time as well, and we'll provide more update next time, but we did see some elevation of water quality issues in LA County beaches this year as well. Thank you.
Thanks so much. Marin County.
Hi, good morning. My name is Aarti Kundu. I am the project manager in Environmental Health Services in Marin County. We just started our beach monitoring program in April of this year. And so far, I don't have any other updates. It's going well for us. Thank you.
Awesome. Thanks so much, Artie. Mendocino.
Yes, good morning. I'm Marlena Dooley. I'm the Director of Environmental Health here. I oversee our ocean monitoring program, and I believe this is the first time that I've attended this meeting. So nice to meet you, and thank you for the invite.
Thanks, Marlena. Nice to see you. Monterey. Anyone from Monterey County here today? All right, Orange County.
Hi, everyone. My name is Alan Marr. I'm with Orange County Environmental Health. For last year, we had about 78 rain advisory days. I think the whole state had a lot more rain, as everyone knows. For Orange County, we also had 4 SSOs in 2023. And then there was a somewhat recent oil spill with cleanup actions conducted by the Coast Guard here in Huntington Beach. Other than that, it's good to see some new faces and have some more involvement in the program. I think there's some other people from Orange County here if they want to give any updates. Thanks.
Thanks, Alan.
This is Joe Guzman with the Orange County Public Health Lab. We support Alan's program with the beach monitoring. We also support our Public Works agency that monitors storm drains and creeks for more source tracking. But as far as updates, we're bringing on a lot of new equipment to try to make our testing more efficient, our quality control, quality assurance testing as well. So that's all. Thanks.
Thanks so much, Joe. If that is all from Orange County, I'll go to San Diego.
Hi, everybody. I'm Joel Wright. I'm the program coordinator for our Beach and Bay program at the County of San Diego Department of Environmental Health and Quality. I took over the program a couple months ago, so this is my first meeting. I'm happy to be here and happy to meet you all. I also have Marie Marquez here, who's our Environmental Health Specialist 3, and then Romina Scheiss, who's a supervisor for our Beach and Bay program, will be joining shortly. Glad to be here.
Great. Thanks, Joel.
Marie Marquez, as Joel said, I'm an Environmental Health Specialist 3 with the Beach and Bay program. As far as updates in San Diego, we've had about 9 rain advisories and about 7 water contact closures so far in the county.
Thanks so much.
Thanks.
And San Francisco.
Hey, good morning, everybody. I have a couple of updates and one quick question, if I may, to the group, Michelle. Is that okay?
Yeah.
Okay, first update, our website will be changing. I believe the My Water Quality portal has a link to our site. So July 1st, it will change from .org to .gov. Should be a minor impact for the users who access it. The question to the group is, we are we're trying to collect more sample volume at our sites. We're currently using the 120 ml container. We want to go to maybe 200 mils, but we're having, I don't know, problems, but issues trying to find a container that's graded as sterile. Does anybody have, or they can put it in the, drop it in the chat for me or email. So yeah, we want to increase to at least 200 mils of sample volume. We're currently doing the MF and Intero Alert IDEX method. And then the last update is this is my last meeting with you folks. I see a lot of newbies here, but I'm actually retiring at the end of next month. So it's been a
Congrats,
long,
Diane.
thanks, Michelle. And so I believe I'm from the PUC. I am still the lead of the shoreline program, biologist, and I have a cohort online here today. It's going to be taken over for me. Jess, are you available? I don't know if Jessica's there, but Jessica Donnell, I don't, maybe she's having issues. But she's online today, and Corey is off on vacation from DPH, so it's just me.
Perfect. And Diane, it does look like there's a couple of responses to your
Oh,
questions
great.
in the chat.
Okay, great.
So,
Great. Thank you.
And I do think I see Jessica on, but it looks like she may be having
Issues
on
there? Yeah.
yeah, freezing. So
Actually, I don't see the answers there, Michelle. I'm not seeing anything in
oh, you
chat.
don't? Okay. I will
No.
send them over to you.
Thank you very much.
Okay, perfect. And then San Luis Obispo. Okay, San Mateo.
Morning, this is Allison Fang and Stella Pohl, San Mateo County Environmental Health. Not too many updates here, but we're happy to be here. Thanks for having us.
Thanks so much. And Santa Barbara.
Good morning, Jason Johnston with Santa Barbara. No updates.
Awesome, thank you. Okay, Santa Cruz.
Hi, this is Audrey Levine from County of Santa Cruz, and things are cruising along here as normal. But the main question I have for the group is we're seeing dead pelicans on our beaches. I don't know if other people are seeing them, but just curious if that's sort of, if anyone has any experience with that, because we're getting questions and we're not sure what's causing it, but it's like not trivial there. So yes, that's my main question, but otherwise we're moving along as usual. And yeah, for the containers, we use Whirl Packs and they come in different volumes. And so there's a 300 milliliter volume that seems to be fine. So anyway, that's my updates.
Thank you. Okay, Sonoma. Ventura.
Good morning. I'm Roxy Cabral with Ventura County Environmental Health. I'm here with Christina Colombo and Ashley Kennedy. We had one sewage release back in February, but that's it.
Perfect. Okay, and then anyone else from the State Water Board?
Eric Burris here. Glad to see everybody this morning. The only announcement I have for the Safe to Swim network is we're working on revising the website, the water quality portal as well, and that the workshop we've been trying to put together with EPA for the last year and a half for the sanitary survey has been punted, and we're going to be hosting it this fall locally in Southern California within the Inland Empire, Orange County area. So when we have a firm date for that, we'll make announcements. It's kind of a wide target. We're looking at citizen monitoring groups, EJ, tribes, and other community groups, as well as agencies.
Great, thanks, Eric.
You're welcome.
Anyone from the US EPA today? I don't think they could join, but just double checking. All right, and then anyone else that I have not called? All right, great. Oh, yeah, Sharon.
Yeah, Sharon Green with Los Angeles County Sanitation District. So thought I'd listen in today. It sounds like an interesting agenda. Thanks.
Thanks so much, Sharon. Okay, so thank you everyone for being here. I have just a few informational items before we get started. So first, in terms of invoicing and reminders about grant agreements, if you've not already submitted your invoice for January through March, please do so as soon as possible. Our next invoices are going to be due July 20th. If you need a budget shift, please plan to do so at least a week prior to invoice deadlines. For LA and San Diego County, we're currently working on your fiscal year 23-24 grant agreements. So please be on the lookout for emails from our budgets and accounting office in order to get those executed on time. And then for all of our other grantees with 3-year grant agreements, we will be starting to do work on the fiscal or the 2025-2028 grant agreements starting this summer. So be on the lookout for any emails regarding those. And then just another quick reminder to please use the beach monitoring email for all program correspondences. That way, if I am not in the office, someone else can get to your questions quickly. And then there was a QA program plan, our phase 2 QA program plan that was approved and distributed in January. So please take time to review that. We're currently working with our IT department to make the changes that we've included in that document. So once they've been rolled out, we're going to provide a presentation and walk through any of the relevant changes for any staff that may need to be updated on these. And then we are currently in the process of our phase 3 document. We'll send out an overview of any upcoming changes. And we'll host 2 office hours again, like we did last year. Those dates and times will be announced as we have not gotten that far yet to planning. We will be implementing phase 3, or we won't be implementing phase 3 until phase 2 has been completely integrated into the program. So we're not trying to rush you. I just want to give you an update of where we are on our QA program plan on the State Water Board side. And we will be providing more information in the future about how this is going to affect any QA project plans for each of the local agencies. If you have any questions about that, please feel free to reach out to me. We can set up a meeting to discuss it further. And then there's been some talk about third-party data usage within the beach program. And so we are currently preparing a memo on this topic, and that'll go out to all of our local agencies sometime this summer. But Orange County will also be providing a presentation today at 11 regarding their unified monitoring program. So be sure to listen in if that is something of interest to you. And then with that, I just want to open up for any questions in the next 10 minutes before we move on to our first presenter. All right, hearing no questions at this time, I'm going to hand it over to Dan, the founder of and CEO of Fluidian US. He'll be presenting on Alert, which is a rapid portable microbiology tool for illicit discharge detection and quantitative risk assessment. So go ahead and take it away.
Hello, thank you very much, Michelle, for the introduction. Can you please confirm that you can hear me and see me okay?
Yes, we can.
Wonderful, thank you. Well, I will present a few slides, but before that, I wanted to say that I'm very excited to present today. I'm presenting on a topic that hopefully will suscite a little bit of interest, specifically rapid microbiology and how to measure E. coli and enterococci rapidly, directly in the field, even in remote locations with the portable and handheld instrumentation. So these are some important technology advances that we've made, and I'm really excited to share them with you. So with that, I will present, Michelle, could you please allow me to share my screen? I think it's not allowed right now.
You should be able to now, Dan.
Right. Appreciate it. Thank you so much. Okay. All right. Let me know, please, if you can see my title slide.
Yep, we can see it.
Wonderful. So I'm going to talk about the alert technology that we've been developing for over 8 years now, and which allows to rapidly measure contamination from sewage and fecal matter in recreational waters, drinking water, but also in other water matrices such as irrigation water, for example. I am Dan Angelescu. I'm the CEO and founder of Fluidian, and we have offices in Los Angeles in the United States and in Paris, France, Europe. So this is no secret. Everybody here knows that water sampling is, complex. When you need to do microbiology measurement, you need to send people out, collect samples, bring them in a cooler to the lab. Then it takes time, it costs money, and usually the results arrive only several days later. That means that, it could be too late for any kind of preventive action. There are faster methods, such as molecular methods, that are becoming more and more available and accessible, but they require the use of a laboratory, well-equipped laboratory, and quite complex extraction and sample preparation protocols to be performed, so they require specialized personnel, and they're not available at remote locations. So, how can we improve on this? So today, like I mentioned, the whole process involves sending people out to collect a sample, transported it in a cooler to a lab. Then you need to fill in chain of custody paperwork. The lab needs to prepare the sample or hold it in a fridge until it's ready. Then you need to go and incubate it, mix it with reagent, incubate it, and then finally you read the results. In this case, I'm showing an MPN result from ColAlert QuantiTray, and finally you interpret those results, you read them in the table, and you can send them to the interested customer or final user. So all of this, not only it takes a long time, it involves costs at each of these steps. Sending people out involves cost, involves personnel, transportation costs, sending the sample another cost, and everything here costs, and results in the best cases arrive after 24 hours, more likely after 72 hours. So how can we do better? Well, one way to do it better is to use technology. And what we've developed is a technology that allows you to get lab equivalent results within 2 to 12 hours. And we have instrumentation that is, ready for the field, either to be installed autonomously in the field, and then it does the sampling and measurements automatically, or that is portable or even handheld. So this allows you to get these results significantly faster using a slightly different protocol, but that is really easy to implement in the field and provides equivalent results. So we have 3 different instruments, like I mentioned. So we have the most complex one is our in situ field analyzer. It's shown here in the Echo Park Lake in Los Angeles, where it's been used for several years continuously. And it has 7 cartridges like this one, and it can sample in each of these cartridges. It can sample a water sample, mix it with the reagent, and perform incubation and optical detection, and provide the results within a few hours. So this instrument also communicates data remotely. It is what we call Internet of Things compatible. So it can connect to our server. It can be controlled remotely. So you can start a measurement, just before, just after a storm. So you can actually track certain events when you think that they could contaminate the recreational waters. Going down in cost and complexity, we have a portable field analyzer that can measure 6 samples that you can collect manually. And you can, for example, go to multiple sites, collect a sample, put it in an incubator, start the measurement, and then move on to the next site while the first sample is being incubated. So this allows you to record lots of data at different sites, whereas the first unit allows you to record time series at a given location. And finally, a very brand new addition to our instrumentation line is the Alert One, which is really a handheld analyzer. It is really small. It's the size of a beer bottle, a little bit bigger than a beer bottle. And it allows you to measure one sample, but it operates anywhere, doesn't require to have a SIM card or communication capabilities. It does all the quantification inside the unit. So these are about an order of magnitude apart in price. So the unit on the left costs about 10 times as much as the unit on the right. So the unit on the right is really low cost, just bare bones, and allows you to quickly deploy measurements wherever you are. The unit on the left requires installation. In this case, it's attached to a buoy. So like I mentioned, many of these instruments, and specifically the two instruments on the left that I've shown, they communicate data remotely, can be controlled remotely. So you have a data interface. From there, you can start a measurement, you can schedule new measurements, you can get the data and get automatic reports and alerts for when the measurement is ready. So really, within hours, you can have information about the water quality at multiple sites. So the advantage of doing this versus the standard, grab sample and lab analysis is that, the results, you get them within a couple of hours, within a few hours versus days or weeks sometimes for the lab. There is no risk associated with sample collection, whereas if you wanted to storm, let's say during a storm event, you need to send teams out in a storm, collect samples. It could be dangerous. It could be at night. It could be with, really, really turbulent water, high flow, etc. The logistics is minimized. You don't need to ship the sample anymore because the measurement is started directly in the field. The cost is minimized. You only pay for the reagent or the cartridge. And finally, you eliminate any kind of risk of human error. And last line there, it's actually the accuracy of the alert method is interestingly sometimes better than the lab method for a number of reasons that I'm going to explain, and specifically because the current culture-based laboratory methods, being membrane filtration or most probable number like colloidal quantity, they're unable to measure multiple bacteria attached to aggregates. And as we're going to see, these can be prevalent in many water sources. So it helps then to look at all the available measurement methods for microbiology today that can be applied to recreational waters. So, the traditional EPA-approved ones are membrane filtration and most probable number. This is IDEX quantitrace and MPN method. And, they have the advantage that they're approved. They're specific to viable and culturable cells. And this is what has been associated through epidemiological studies with the risk to human health, right? So this is what you'd like to measure ideally. It's relatively simple lab work. However, it takes a long time to get results and they're expensive. Then you have the molecular methods, and the most common ones are qPCR and digital droplet PCR. These, they're not yet approved, but there are protocols proposed by the EPA to measure both bacteria and human markers using these. They're sensitive to aggregates, so they would measure bacteria even if multiple bacteria are clumped together. but they are not specific to culturable cells. They would measure DNA from dead cells or non-viable cells as well. So if you do things like UV disinfection of wastewater, you might not see the results because the DNA is still there. Then there are some really quick and dirty methods like, direct enzymatic and tryptophan-like fluorescence. These allow very quick measurements, but they just measure a proxy. They're not really well correlated with any kind of bacterial count, so they cannot be used for managing the bathing water site, for example. And finally, there is our method that we've developed, the alert method, which passes the site-specific EPA test for alternative methods, and it's also been validated by the World Health Organization. It is sensitive to aggregates, as we're going to see, and it's specific to viable and culturable cells, but provides results much faster. Well, you need to pay for the instrumentation, and there may be periodic system maintenance for the in situ systems. So now let's see how the alert method actually operates. The way it operates is that a sample is mixed with the culture medium, with a growth medium, and with an enzymatic substrate. The whole sample is mixed together, and then we're incubating it at the 37 degrees, which is the ideal temperature for E. coli in this case to develop. We're looking at E. coli, but the same applies to Enterococci. So, as the bacteria are incubated and they have plenty of food, they start dividing, and they divide on a clock. They don't compete for food, so they will divide, on a very regular basis. So after a certain amount of time, let's say after 15 minutes, from one bacterium you have 2, from 2 then you have 4, from 4 you have 8. So you have this exponential growth. And these bacteria consume the enzymatic substrate, which is also mixed with a growth medium. So they generate more and more fluorescence in case of E. coli, or they generate a yellow compound, which is in the case of total coliforms. The reagent is similar to what IDEX uses, for example, for the ColiAlert QuantiTray. It uses similar enzymatic substrates. These are the molecules that we use. Except that what we do is we look at the whole sample and we look at these fluorescence and absorbance measurements in real time, and we construct curves like what you see here on the left. And based on how many division cycles it takes to reach this threshold where the fluorescence shoots up, that tells us how many bacteria there were there. So the longer it takes, the more division cycles, it means the fewer bacteria were there initially. When you have a lot of bacteria, you only need a few division cycles, so you get the signal much faster. So basically this detection here, this vertical line moves to the left for high concentrations and moves to the right for low concentrations. So based on this time, you can actually tell how many bacteria you have. And more importantly, because you're measuring the activity of all the bacteria, even the ones attached to a particle, will divide and will create this optical signature. You will actually be sensitive to all the bacteria in the sample, including the aggregate bound E. coli. This is something that we call comprehensive E. coli measurements. It's also something that molecular methods do, because you homogenize the sample fully and then you measure individual DNA molecules. So both alert and the molecular methods will measure comprehensive E. coli or Enterococci, comprehensive fecal indicators. So how important is this issue of aggregates? Well, normally when you look at a water sample, that's what you'd like to see. You filter it on a membrane, then you stain the bacteria with DNA stain, and then you look at it under fluorescent microscopy. So ideally, this is what you should see. These are individual bacteria. They're about 2 microns long. This could be E. coli. They could be something else, but they're dispersed uniformly and they're individually suspended in the solution. But sometimes you see something like that. And that's an example of an aggregate. And when you have fecal matter in the water that breaks down mechanically, for example, after a sanitary sewer overflow, you will have a lot of that. After a storm, you'll have a lot of that. So you have, essentially solid fecal matter that decomposes into smaller and smaller particles. Well, you'll have a lot of aggregates in that case. And why are these important? Well, imagine that you're doing, on the left here, we have an MPN, example. So this could be the wells of a quantity tray. And on the right here, we have membrane filtration. So this could be your sample filtered on a membrane. So what happens here is that once in a while, you'll get one of these aggregates and it will end up in one of these wells or at one place on the membrane. So when you put this and you incubate it, what it will look like then, it's this. You're going to detect a single positive here or one colony for membrane filtration. So there is no way for you using these methods to know whether this was a single bacterium like this one, or it was an aggregate that may have 10 or 100 bacteria attached to it. So this is actually a major risk that the current methods cannot measure, but comprehensive method like qPCR or digital droplet PCR or alert can actually correctly ascertain. So in raw sewage, you have, raw sewage is highly non-homogeneous. And so when it breaks down into smaller and smaller particles. At some point, the forces, the shear forces in the flow, the mechanical forces are not sufficient to break down the particles even more. Large particles will settle down, but smaller particles will actually remain suspended. And what we find is that a lot of bacteria are on particles of sizes between 5 and 10 microns. So actually those can carry up to 5, 6 E. coli and all the associated pathogens on them. So it's not really the fecal indicators we're afraid of, but these pathogens, and these are associated with particles. And what's more is that these particles, they also protect their content, right? They create this microchemical environment. They protect the content from chlorine, from oxidizing. They protect them from UV light. So basically, these pathogens will be protected within a particle, and you will not be able to measure them using the standard fecal indicator methods. So let's take a look at, how a microscope sees this. So we're looking at a sample here. So what you see here is, plenty of individual bacteria. And we're moving along on a slide where we're looking actually at a filtration membrane with these bacteria attached to it. This is actually a river sample from the Seine River collected at the Olympic site where the 2024 Olympics will happen. And it was collected last fall. So, now we start to see something interesting. And again, this is a big bacterial aggregate. So it has plenty of different bacteria attached to it, and it's really big. So this is how a fecal particle actually looks like. And this is what currently we cannot measure using the standard methods. So now let's see how well the alert method compares to the MPN method. And in order to have a fair comparison, we're going to remove the aggregates so that we don't have this discrepancy that comes from the fact that alert can measure aggregates and the MPN method cannot. So here we're comparing with the most probable number method like colloidal quantity tray after removing all aggregates by 5 micron filtration. So everything larger than 5 micron will be retained, but everything smaller and all free bacteria we're talking about are smaller than 5 micron, they'll go through the filter and they will be in the sample. And when we do that, what we see is that we get excellent linearity here. And something else interesting, the vertical here is, this is by the way, this is the log 10 of the E. coli number. So this goes from 100 here at 2 to 10,000 E. coli per 100 ml, and same thing here. So what we see is that, at low concentrations, you get measurement uncertainties that are similar to what the MPN method gets. That's what we see here. But then as we increase the concentration, what we see is that the error bars for the alert method actually get a lot smaller for higher concentration. It becomes much more precise, much more repeatable, whereas the lab stays more or less the same. So we're actually more accurate for higher concentrations than the lab currently is. So let's take a look at some examples where these bacteria on aggregate are actually really important. Here, we're looking at samples collected by UC Davis in irrigation canals in Central Valley. This is not recreational waters, but they are waters where we care a lot about the water quality because this is what's used to irrigate some crops which end up on your plate and may still contain the bacteria. So it's these bacteria that are actually responsible for the food outbreaks for romaine lettuce and other things like that that you may have heard, and for huge product recalls. And it's important to know if you have an aggregate or not, because an aggregate will be protected and has much more chances to actually be transported all the way to your plate and get you sick than a simple, a simple bacterium. So here we're looking at samples filtered at 5 microns, and we've seen this measures exactly the same as the standard lab method. And here is unfiltered samples. And what we see is that when you look at samples from irrigation canals, we measure much higher values, sometimes by almost a factor of 1,000 higher on unfiltered samples. So these are bacterial charges that are in aggregate than filtered. Whereas for reservoir samples, where these particles have had a lot of time to settle down, we measure the same thing. So, these aggregates are present in these canal waters and sometimes in really high quantity. So they are a risk that you cannot see using the standard methods today. Same thing, you look at the beaches. Here we're in Brighton, and we're looking at beach measurements during a swimming race performed there. And what you see is that with the filtered samples at 5 microns, we don't see any bacterium. So there is no free bacteria in this water. But when you actually measure the unfiltered sample, you see a relatively high count of bacteria. And these are bacteria that have been resuspended from sediment. They were, essentially fecal particles from a recent combined sewer overflow that probably settled down, and with the surf action, they got resuspended. So they're only present in aggregate form, and that's what we see here. Other examples, we're doing daily monitoring upstream of the Olympics in Paris. We have a company in Paris, as you may remember, and we're sampling daily. And we've been doing that for the city of Paris since 2017. And now we're still doing it for the bathing water site in Paris. But for the Seine River, we've actually started a citizen science campaign, and we're creating a completely open data for daily measurement data, both filtered and unfiltered. So we understand not just the water quality, but also how much of the water is affected by the presence of these aggregates, which we think are particularly dangerous and not very well known. And, first, let's take a look a little bit upstream of Paris. So here you can see our Alert V2. This is our in situ analyzer, and it was installed here. This is the Seine River. What we see in the background there is the city of Orly, where there is a big airport. And it's a city that has combined sewers. So when it rains, there is combined sewage overflow. And here, these are lock gates to the right. The boats go on the right, and the river goes on the left. So this is undisturbed by the boats that go by. So what we've done is we've measured every single day using the automated Alert V2 for 2 months. And the laboratory came every week and collected a sample at the same time. So we have essentially 9 side-by-side samples where the lab and our system measured at the same time. And this is what you see here. These are the 9 samples. And we see that, the water quality is not very good. It's, around 2,000 E. coli per 100 ml. This is, a factor of 15 above what the US regulations require. But we measure the same thing, and looks like water quality is relatively constant. So let's look, and look at this data as a time series. So this is the laboratory sampling. So what you see indeed, water quality seems to be relatively constant and, in the couple thousand. And then remember that this is every 7th day. So it's like listening to a piano concert, but only hearing every 7th note, right? You don't hear the music. If you want to hear the music, you need to hear every note. And this is what we have here. Here we have the measurement from the alert system. Sometimes it collected multiple samples a day. So, there are some times when you may have 2 samples close to each other, and then for the next day we don't have a sample. But pretty much on average it was once a day. And what we see here is that we have really a lot of short-term pollution events that last for 2 or 3 days and that are not captured by the lab because the lab just didn't sample on those dates. So weekly sampling is highly insufficient to ensure water quality at a site like this. Now, let's try to look at the rain events as well. Here we have rain events at Orly. And what you see is that the rain actually correlates really well with the presence of these peaks. So we have, a first rain event here, it generates its peak, which lasts for 3 days. Here we have a smaller rain event, but it lasts a little bit longer and it generates another peak. So these are actually combined shore overflows. We see their effect, but the lab completely missed them because of the frequency of sampling, which is insufficient. So high frequency is important, and our technology allows to get high frequency data. But then let's take a look at a whole year of data. This is 2 systems that we had installed for the city of Paris, where we measure, they're about a mile apart, and the green one is actually close to the current Olympic site, where the Olympic aquatic events will be held in the Seine in this year. And what you see here, this is data from 2019, okay? So we have a big rain event here coming, in May, and you see that water quality degrades a lot. We have relatively good water quality in the few hundreds per 100 ml. I'm saying relatively because, again, standards in Europe and the US are different, and in Europe, this is acceptable quality. It's this red line that defines what is acceptable quality. So, but you see that this rain event creates a huge overshoot of E. coli levels on both systems here. Then it takes about a week to go down. Let's take a look at 2020. Well, in 2020, we saw something interesting. In 2020, we saw water quality here being in the 100. This would be acceptable even by US standards. And we wonder why. And it's actually relatively easy to understand why. We still have CSO events, but here we have a long dry spell. And that actually coincided with the Paris COVID lockdown. So lots of fewer people in Paris, no businesses open, no restaurants, less sewage. And that combined with the fact that it was completely dry weather led to this really incredible improvement in water quality, something we've never seen before and we've never seen since. So getting this kind of high frequency data allows you to actually do a lot of things, for stormwater. You can, for example, measure events, stormwater events like this, and understand when the first flush is. You can understand exactly when the most E. coli gets in. And then you can actually, from this pollutograph, you can define the portion of the stormwater flow that needs to be captured. So you don't design oversized capture storage facilities, and water capture, but you actually minimize them and you operate them intelligently based on data. So this allows you to optimize the capture project, to improve the return on investment as well, and to mitigate public health risk. So it could be used like that to really improve all the water capture projects. Stormwater capture projects in California, for example. But other examples of using alert technology. Here we're looking at our handheld unit. So just a couple of words about this unit. This is a technology that we have developed actually for the United Nations at their request, because they want to be able to monitor water quality in developing countries where people actually drink surface water without any treatment. So being able to have a quantitative measurement of E. coli is essential in order to prioritize the water sources. In some countries like Sierra Leone, almost no water sources are uncontaminated. 80% of people drink water contaminated with E. coli. So it's really important to be able to help there. So we developed this portable system and handheld system, and then we discovered that it has plenty of other applications. In this case, we're looking, at the impact of discharges from living boats. These are barges where people live in ports like this and along the Seine and the Marne River, in Amsterdam as well, in London in some places, and they release their sewage with some forms of treatment in the river. So we use this technology in order to measure the impact. We also used a lot of other technologies here. You see fluorescein tracing, so we can actually understand the dilution factor. So we can make really complex studies based on this technology and measuring E. coli in situ along with the fluorescent concentration, for example. we're working also with the water utilities in the UK, where, polluted rivers have become a real big political issue because there hasn't been enough oversight from the Environment Agency, and therefore a lot of the utilities are actually not being properly regulated, and sometimes they discharge a lot of sewage in the rivers. And then in addition to that, there are illicit connections to the rain network, to the storm network, from sewage, right? So old houses that have been connected to the wrong network and that release their sewage directly in the rivers or coastal waters, and that creates really big pollution events. So, Southern Water, for example, is using our instruments in order to find these illicit connections within the network. They sample in all the manholes, stormwater manholes, and then they see where there is sewage, and then they follow that through the network in order to identify the culprit, and then they can do work in order to connect properly. Other examples, we're also working with a lot of NGOs and a lot of swimming groups. In this case, this is Whitstable. SOS Whitstable is based in Canterbury, and we're working with their city council in order to test their beaches. And we're also working with the Isle of Wight Animal Sanctuary, and these are people that are taking groups of elderly people ocean swimming every single day of the week, and they test their waters using our instrumentation in order to know what the water quality is on that day, so they know if they're taking any risks or not, and they may cancel their swim if the water quality is not good enough. Other examples, this is a UK Environment Agency that uses both our in-situ system. In this case, it's in a water quality measurement kiosk that's equipped with a pump. So it pumps water from the bay into this plastic box where we have our alert system. You can also see a YSI EXO2 probe. So they measure the water quality parameters, then they pump it back out, and they repeat this on a regular interval. When they see a hit here, then they set their mobile unit, they send it up the different canals and rivers, and they use our portable instruments in order to see where the pollution originated. This is an interesting one. This is very recent stuff. So this was just a couple of weeks ago on the BBC Breakfast show. River Action is an NGO in UK that does a lot of river sampling. And recently they did a sampling campaign in the Thames River using our Alert One analyzers, our handheld analyzer that you can see here. And they discovered lots of release points for sewage in the Thames, and their average was 3,000, almost 3,000 E. coli per 100 ml from 16 tests they performed. And they did this test just before the boat race between Oxford and Cambridge, which is like one of the big traditional events that happen in the Thames River. So based on that, they actually had to change the regulations of the boat race, and the winners were not allowed to jump in the river. They had to cover their wounds. I mean, they had to take special precautions because of these high coli content discovered. Here you have the CEO of River Action, and I'm just going to play this. This played on the BBC Breakfast, and listen carefully to the words used.
Well, I think like most people around here, I just thought it was pretty grim. The local residents refer to it as being the crappuccino. For several days after an outage, the water around the eddies will be brown and fluffy, and you kind of think, oh, that's not very nice. There's poo floating into our river. But when you actually start to break it down and run the numbers, you find that it's just way worse than that. It's all the very worst of things that pass through the human system are going out into what we consider to be our river.
Right, so you can see that this is a real problem, and when you talk at BBC Breakfast about crappuccino, that is, that actually makes the headlines.
Well, I think
sorry. Now I'm going to jump over to the United States, and I'm going to present some of the work that we've been doing. In this case, is with the California Water Quality Control Board in San Diego. and who has been using our alert system, actually a previous version of the technology, our earliest version of the technology, in order to test the Tijuana River, and they got a high correlation coefficient. So they measured the, concentrations up to 1 million and above 1 million E. coli per 100 ml. This is essentially raw sewage that was coming down some of the canyons in the Tijuana River. And the nice thing about the alert was that it measured this in a single measurement without the need for any dilution. Whereas when you do this with call alert, for example, you need to do 3 or 4 dilutions in order to be able to cover that. So it's also makes measurements much simpler. The system is used in Lake Chelan. We're working with Lake Chelan Research Institute, who are testing the bathing waters in Lake Chelan regularly using our alert lab. Other examples, this is on the right, you see our alert system V2. So this is the in situ system. This is an Echo Park Lake. Like I mentioned, it's being used by LA Sanitation there, and it measures regularly, and it's had very good correlation with the lab results. And this is an example of deployment in South Carolina by Wilpert, who is one of our distributors now and a customer as well. And they installed the system, out of a canoe. So it's quite interesting. People get creative once you have this kind of technology. Here we're working with the United States Geological Survey and with the Delaware River Basin Commission, who are using our instruments in order to measure at multiple sites along the Delaware River. But these are also used in the Harlem River, in the Anacostia, and in other places along the East Coast, and with quite good results. So with that, I would like to thank you very much for your attention, and I'm here to answer any kind of questions. And also, I'd like to mention that we're very interesting to partner up with agencies and also with potential citizen science groups and NGOs in California in order to release this technology and have it trialed at multiple locations. So don't hesitate if you have any questions, please. Thank you very much.
Thank you so much, Dan. And we do have a few minutes for questions. If anyone has any, feel free to unmute yourself and ask Dan some questions.
Okay. Looks like there is a question.
Yeah, Ashley, go ahead.
Yeah, this was really great. Thank you so much. I was wondering, would the alert lab be something useful to our sampling programs where we are weekly sampling, multiple locations along the beach? And also, how much would that cost?
Sure. So the alert lab is this middle instrument. So it's a portable instrument that can measure up to 6 samples. It definitely can be used to measure at multiple locations, like what you described. The cost with all the bells and whistles is a little over $14,000, and the cost per sample is about $14, I think.
Okay,
So
thank you.
that gives you the instrument cost and the running cost as well.
Perfect, thank you.
No other questions?
You have a couple in the chat. How long can a given cartridge be used for sampling?
So the lifespan of a cartridge is typically 3 months from manufacture. So if we're talking about cartridges for the in situ system, we ship those fresh. So basically, you order, let's say another set of 7 cartridges, and then we ship them within a few days. And so you have them fresh, and you can use them within 3 months. For seawater, it is 1 month. It's a slightly different cartridge, different composition, and For the other instruments, yes, the reagent lifetime is also 3 months.
And then I see Lucy's hand.
Thank you, Michelle. And this, thank you, Dan. It was a great presentation. Michelle, this is my question is to you. Would this be something that's state approved before counties participate in using?
And Hal just asked a similar question in the chat. I would have to look more thoroughly into this if California would consider this an option for the beach program, but I can look more into it and talk more with Dan on the side and determine if this is usable for the beach program.
Understood. Thank you.
Yeah, thanks.
So we're definitely interested in this possibility and in having the system evaluated against against the standard methods. We also think that we bring something that is like I mentioned with the measurement of aggregates is actually a additional measure of risk that's currently not captured by the standard lab methods. So that is also something to be considered from the perspective of public health.
Awesome. Thanks, Dan. We can take one more question if anyone has it. All right. Thank you so much, Dan, again, for your presentation. If anyone has any questions for Dan, his contact information is on the agenda. We're going to move over to our presentation by Maria Rodriguez with the Ocean Protection Council. She's the Climate and Environmental Justice Program Manager and will be giving us an overview on the 2023 Annual State of the Coast and Ocean Report. Take it away, Maria.
Thank you, Michelle. Let me figure out, can I do a screen share? I think I'm disabled. And
I just made you a co-host, so go ahead.
okay, thank you. Okay. Does everyone see my slides?
Yes, we can see them.
Great, thank you. All right. Just get some of these things out of my way. All right, well, good morning, everyone. Thank you for having me. My name is Maria Rodriguez. I am OPC's, that's the Ocean Protection Council's Climate and Environmental Justice Program Manager. And today I'll be presenting on the public beach access and beach water quality indicators from our 2023 Annual State of the Coast and Ocean Report. Also joining me in this meeting today is Dr. Laura Bliss, who is the West Coast Ocean Data Portal Project Coordinator from the West Coast Ocean Alliance. Laura significantly helped guide the development of the public beach access indicator analysis and has been working on similar analyses for the state of Oregon and Washington. And we also have Dr. Allison Zunyi Wu joining on this call. Allison is a water quality data specialist for Heal the Bay and had a significant role in helping us develop the beach water quality indicator based on their expertise in analyzing water quality sampling data that has informed Heal the Bay's annual beach report cards. They may jump in at any time during this presentation to address details in the methodology or any technical questions related to the analysis. Thank you, Laura and Allison, for being with us today. For a bit of background, OPC's Annual State of the Coast and Ocean Report is a strategic priority and direct target from our strategic plan, specifically Goal 3, which is focused on enhancing coastal and marine biodiversity. The target calls for OPC to create an annual report starting in 2021, highlighting strategic plan implementation progress, critical issues, and developing a report card by 2025 that uses a scientific indicator-based approach for grading. Our 2021 report focused mainly on a retrospective of OPC activities and accomplishments in meeting strategic plan goals. With further direction and feedback from our council, our 2022 and 2023 reports build on the previous model, But in these reports, we begin to incorporate a suite of preliminary indicators that provide a snapshot of ocean health in California, as well as OPC activities and accomplishments. Our 2022 and 2023 reports were a collective effort led by OPC summer interns, OPC staff, a partnership with the West Coast Ocean Alliance, and consultation with the OPC Science Advisory Team. The development of indicators requires high-quality monitoring data that is both spatially and temporally robust. Indicators included in our 2023 report, as shown on this slide, represent a first step. They do not reflect final indicator development or selection for the purposes of the 2025 report card. For this presentation, I will focus on discussing the public beach access and beach water quality indicators from our 2023 report. The public beach access indicator is directly associated with our strategic plan goal 2 to advance equity across ocean and coastal policies and actions, specifically the objective 2.3 to improve coastal access. So for the past 2 years, we've been thinking through how to develop and evolve a coastal access indicator that can address questions such as the status of California's current coastal access, like how much coast and or beach is available for the public, spatial distribution, such as differences among North, Central, and Southern California, and speak to any trends, like are we seeing improvements for coastal access over time? And all of these questions help narrow the focus for this particular analysis because it depended on the availability and access to long-term data, how we decided on defining coastal access. Sorry, wrong slide, not there yet. How we decided on defining coastal access and the types of access has served as significant parameters to determine the level of access that is truly accessible for the average beachgoer. So coastal access takes many forms, right? Ranging from public beaches and parks, rugged cliffs, to scenic coastal trails and protected marine reserves. For the purposes of this indicator, we chose to define coastal access as shoreline mileage of physical beach access, such as toes in the sand on the outer California coast within a quarter mile of an access point. This was based on research that shows a quarter mile as acceptable walking distance for an average American. And caveat that this analysis is focused on the outer California coast, as it does not include islands or the San Francisco Bay shoreline. So since we decided to focus solely on physical beach access, we did not include other types of access points, such as points that represented visual access, boats, or piers. The data used was the Coastal Commission's access points, which can be explored through the Commission's Your Coast Viewer online or via a mobile app. The location and attribute data are collected primarily from entries in the 2014 statewide California Coastal Access Guide and a 4-book set of regional Experience the California Coast guides, dates ranging from 2005 to 2012. We actually worked really closely with their staff who provided us a copy of this data set that was slightly more updated than the web version and contained details and attributes such as parking information, restrooms, disability access, parking fees, etc. And while the data had several listed amenities, we primarily focused on parking, restrooms, and wheelchair accessible facilities for this particular analysis. The Coastal Commission also shared state parks, parking, and entry point data. And we also downloaded the California Coastal Trail segments from their website, which was merged with another shoreline type data set from NOAA known as the Environmental Sensitivity Index. So as previously mentioned, this indicator examines the percentage of total miles of the outer California coastline with public beach access, measured as coastline miles within 1/4 mile of a public beach access point, given the parameters discussed in the previous slides. The pie graphs here show the percent composition in percent of total miles of accessibility type for coastal access in California and in each of the 3 California subregions. The analysis shows that 39% of California's coast has public beach access, with Southern California having the most spatial distribution for public beach access from the 3 subregions. About 15% of California's coast is inaccessible due to the geomorphology, such as rocky cliffs or exposed bedrock. 4% is not open to the public due to military use. There was a small, less than 1% that was not open to the public due to other restrictions, such as protected areas or reserves. And ultimately, that 41% of California's coast has no public beach access. Now, when looking at amenities and facilities, the analysis showed that approximately 89 of California beach access points have at least one basic facility. In this case, all facilities is defined as having a bathroom, parking, and are wheelchair accessible. The some facilities category is defined as at least one of the previously listed facilities, and the no facilities category is defined as none of the 3 facilities. From the existing beaches with public access, only 41% of these beaches had all 3 facilities, parking, restrooms, and wheelchair accessible beaches, and 11.5% of public beach access points did not have any of these facilities. So a key takeaway and trend from this analysis shows that since the Coastal Commission switched from paper publications to digital only, there has been an increase in public beach access points documented. Most of these added sites are not additional beaches or parks, but rather additional access points to better describe and document various locations in the area. For example, a public beach can have multiple access points given the size and length of the beach itself. And those access locations and their specific attributes are reflected in their digital mapping inventory to better inform the public. In terms of considerations for future indicator development, there's potential to examine how sea level rise could decrease accessible coastal mileage, how equity and environmental justice intersect, and identifying new approaches and data to support embedding those social aspects. There's also potential to include the San Francisco Bay shoreline and to expand on access types by including visual coastal access points and trail segments. All right, so on to the next indicator, beach water quality. This indicator also aligns with our strategic plan goal 2, focus on equity, specifically objective 2.4 to enhance healthy human use of the coast and ocean. An important aspect to quality public beach access can also rely on waters that are safe to swim. Poor water quality can be a result of pathogens from fecal pollution and bacteria that can cause direct health risks to beachgoers, contaminate shellfish, and have cascading impacts to tourism and local economies from beach closures and seafood contamination. The bacterium Enterococcus is a common indicator for estimating the total pathogen concentration in coastal waters and shellfish. Enterococcus is not harmful to humans, but indicates the presence of harmful pathogens commonly found in vertebrates such as humans and birds. For this analysis, we used 20-year bacteria data that included Enterococcus exceedance rates across approximately 600 California beaches that have been sampled. This data was derived from 17 coastal counties and 27 different monitoring agencies and serves as a source for Heal the Bay's annual beach report card. Averages are categorized by the monitoring reporting periods, which for summer include the months of April through October. And this specifically is a mandated sampling period according to the California Beach Bathing Water Quality Standards as defined in Assembly Bill 411. The winter periods are from November through March, and AB 411 does not mandate water quality monitoring for recreational purposes during these winter months, usually leading monitoring agencies to decrease or stop sampling, but recreation generally slows down at beaches during the winter time. The graph here shows average Enterococcus exceedance rates for approximately 600 beaches monitored in California did not change substantially in summer months since 2003. In 2022, ocean beach bacterial levels exceeded state water quality objectives approximately 5% of days during the summer swimming season. California beach water quality was impacted and winter exceedance rates increased between 2021 and 2022, in part due to the historic rainfall experienced in coastal California counties during the winter of 2022 that resulted in increased runoff and overflow of sewer infrastructure. Just to mention that exceedance rates for each beach is assessed based on the standards described in 2012 recreational water quality criteria by US EPA. So a key takeaway and trend from this analysis shows that less than 20 California beaches account for 50% of all bacterial exceedances statewide during summer months, which impacts local beach visitation and access. Beaches with the highest exceedance rates in 2022 through 2023 were located in San Mateo, Orange, San Francisco, and San Diego counties, including the mouth of the Tijuana River. In 2022 and 2023, 843 postings occurred statewide between the 2022 summer reporting period and 685 postings occurred between winter reporting periods from November 2022 through March 2023, again statewide. These postings are advisories to not contact the water due to the monitoring showing elevated bacterial levels. Meanwhile, roughly half of all California beaches have observed little to no bacteria exceedances at rates of 0 to 2% over the last 20 years during the mandated monitoring period during summer months. In terms of considerations for future indicator development, there is potential to further examine how changing rainfall patterns and wet weather projections may cause more variation in fecal contamination in coastal waters, how equity and environmental justice intersect, which could include an assessment of beach visitation, including number of visitors and their demographics, and evaluating how our beaches are used by the public to meaningfully assess who is impacted and most vulnerable to poor beach water quality. And in terms of next steps and into the future progress of our report card, we're continuing our partnership with Ocean Science Trust, who has been convening our science advisory team to provide input using best available science on the suite of indicators. But recognizing that our end goal is to build out the 2025 report card, the intent is for these indicators to be both policy relevant and scorable. Collectively, the identified indicators are intended to reflect important aspects of the state's many ocean and coastal features, including our state's diverse ecosystems and multitude of human uses. The recommendations from our science advisory team are not fully inclusive of scoring approaches necessary for the final report card or of analyses of data and trends conducted in a scientifically rigorous way, and therefore will require different approaches and considerations per indicator. These pieces will be further explored through an indicators task force, also convened by Ocean Science Trust, to develop the report card in a collaborative approach involving our task force, our science advisory team, OPC staff, partnering agencies, and the scientific community. And as part of this process, we also anticipate identifying information gaps, monitoring needs, and analysis activities required to assess the health of the state's coast and ocean. That concludes the end of my presentation. Thank you all for your time. I'm happy to take any questions, and I believe our technical experts, Laura and Allison, are also on the call to help address any technical questions related to the analysis.
Thanks so much, Maria. Yes, we are running a bit ahead of schedule, so there is plenty of time for questions if anyone has any.
There's some.
Not seeing any in the chat, and if you do have a question, you can feel free to unmute yourself and ask away.
I can also leave my email in the chat if anyone has any questions after the fact.
Yeah, that would be great. I do also have your email on the agenda, just in case anyone needs that as well. Oh, Looks like there's one in the chat. Where can we find the list of the 20 California beaches that account for 50% of all bacteria exceedances statewide?
I think Allison would be best, but I want to say that the answer to that is probably Heal the Bay's annual report card. Allison, would you agree?
Yes, so we'll be releasing our annual beach report card this June or July with more complete informations of all the beaches in the West Coast, especially for California, focusing on some worst performing beaches that we call beach bombers that may need more attention.
Perfect. Thank you so much, Allison. All right, not seeing any other questions. Thank you again, Maria, so much. For everyone else, Laura just dropped everyone's contact information into the chat in case you have any questions. And with that, we're going to move on to our next presenter. Sarah is the Director of Operations at Kraken Sense and will be presenting on Kraken, their online and on-site qPCR tool. Let me just give you ability to share your screen. You should be able to do that now.
Beautiful. Thank you so much. I'm just going to connect it now. Please let me know if everybody can see my screen.
Yes, we can see it.
Okay, great. Thank you so much for the introduction and for this invitation to be speaking with you all. We're very excited to share our technology and describe our platform. So we have what we're presenting today is the Kraken. And it's a data-driven beach safety security device. It's for online and on-site qPCR testing. So we do have this unit in a number of different applications, and a number of them are for beach monitoring and recreational water monitoring. And I'll quickly describe the capabilities just to give an idea of the entire process. Oh, sorry. So before I really get into any specific details, this is what the Kraken looks like. It's actually an older iteration of what we have now. The screen has been moved inside, but basically I like to describe this as a lab in a box. So wherever you would be typically performing tests, in any case scenario, or if there is no current testing strategies in place, this is a really good solution for starting that implementation. It's just the box that's included. The pipes and the meters and everything behind is not part of the unit. It's part of the deployment site. But this box, our Kraken platform, is capable of processing water directly from the source. It handles everything from sample grab to sample prep. We run the qPCR, and then we display all of the results on a safe and secure dashboard. So this really allows the unit to be a completely remote field deployable device. It's suitable for indoor or outdoor installation. We have a number of weatherproofing options that we can employ as well. So it's a very comprehensive unit. Another very strong capability is the turnaround time for results. So we are able to give you back a result within just a few hours, whereas the alternative is to manually go grab a sample and collect it, send it to a lab, wait a few days for results. And then at that point, it may be too late in order to take action. So having a rapid tool that's directly on site, you're not compromising the sample in any way. You're able to make informed decisions very, very quickly. At this point, all the power is in your hands in order to make a decision if a beach needs to be closed or if levels are rising and it becomes a concern for public health and safety at that point. So our biggest motivation, it's a common theme, is enabling informed decision making. This is what the Kraken really allows somebody to do. Oh, I'll just go back a slide, sorry. I'll just introduce an analogy that I like to bring up a lot. It's the printer. So if you have a wireless printer, basically it's an analogy for the Kraken itself. All of the reagents, everything, all the consumables would be compared to your fluidic cartridges, which are these chips right here. And on these biosensors are where your PCR assay is taking place. So this is a really important component of our platform. And what we've done is we've modified the reagents, we've lyophilized them so that they are actually shelf stable. If you were to take a sample and bring it to a lab and run a qPCR, all the reagents you're going to be using are more likely to be in the fridge or in a freezer. So that modification allows it to be stable at room temperature for 6 months. And we can stack these in these drums. And each biosensor would then be able to give you, would be able to process one full sample. There are a number of different targets that we have available right now, including influenza, RSV, COVID, monkeypox. We have just general E. coli strains as well, or we can get very, very specific, like O157 if needed. And this is not an exhaustive list. Basically, anything that is DNA-based or RNA-based, we're able to detect it very easily. We have a very, very capable scientific team. We do everything in-house. We build the machine in-house. We put together the reagents in-house. Everything is made within our facility. And this really allows us to turn things around very, very quickly. There's also a new area that we're specializing in, and that's for chemical detection as well. So if there's any need for testing things like domoic acid or the spike protein, opioids, PFAS, those can easily be detected with our platform as well. Very easily integratable with the current system. Again, if there isn't a target available, we can turn one around for you within 4 to 6 weeks. And it's a very, very quick turnaround time between our team and the user. We also measure just the physical attributes of the sample. So before it's being processed for qPCR, it goes through sensors for temperature, turbidity, suspended solids, and these are really key for troubleshooting the assay and validating that it's working correctly. But we can also add many different sensors for you as well if it's needed. So just to go through a quick process of what actually happens inside the device. And this is very similar to what would happen in a lab. The entire process, we haven't reinvented the wheel in that sense. We're doing everything that a lab is doing. But where the innovation comes in is the automation part of all of that. So it doesn't require any personnel. It doesn't require any infrastructure or training. And because we have that, so part of the installation process, we have a step where it requires like Wi-Fi, GSM connection, just like you would for a printer. It allows the results to be communicated on a secure dashboard very easily. So you don't even need to be really close to the machine at all. The first step is to just schedule testing. And this is done on a dashboard. When it's time, say I want to test tomorrow at 10 a.m. Tomorrow, 10 a.m. When it comes, the unit itself will automatically take in a sample and it would then begin the processing. The first part of that, as I mentioned before, is just to evaluate the sample quality metrics. So things like temperature, pH, conductivity. Following these metrics, and we have a very wide range of samples that we're able to handle. I'll describe some of the deployments that we've had and some of the challenges that we've come across and how we overcame them. But following these physical attribute testing, we go through lysing steps. So the lysing step will release all of the genetic material into your sample. In the case of chemical testing or small molecule testing, this step would just be modified slightly. We just want to be able to separate the components of your sample that contains your target and stuff that doesn't contain your target. We then concentrate the sample, and this step is really critical for being able to achieve such a quick time to result. A lot of typical methods will employ culturing techniques, which sometimes isn't as accurate when we get down to really low numbers. It becomes very prone to false positives. And it also requires a lot of time, minimum 24 hours. If we're looking at E. coli, that's usually more than sufficient. But if we're looking at other bacteria that have a longer doubling time, you could be waiting a few days to get a result. So that concentration step allows us to be able to take in a very large volume. So if there's 1 copy in a liter, we'll be able to catch that one bacteria that's there and not have to wait or depend on other techniques to reveal it. Following the concentration, the sample is then put into those biosensors, those fluidic discs, and we run the full qPCR analysis there. Our qPCR is very, very sensitive. So I mentioned before that everything is developed in-house. Our scientists develop all of the assays that are very specific to your target. We're also very, very sensitive. So regardless of your sample size, our detection limit is 1 copy, down to 1 copy. So that means that if there's 1 copy of a gene in 1 bacteria, we'll be able to catch it in the volume of sample that you're taking. And this will often be missed with other techniques such as culturing. With every sample, with every biosensor that represents like 1 volume of water, we can detect many different targets. So if we want all of our controls with the technical replicates, we can detect up to 4 targets at a time. But if you want to sacrifice some of your targets that maybe don't require as many replicates or controls, then we can go up to 6 targets for you on a single sample. And all of the samples that do have their controls, it's a self-calibrating system. So the system is continuously calibrated to make sure that the optics are working correctly, that the result that you're getting is very accurate. We run a standard curve prior to you receiving the machine. So the value that you're obtaining, the signal that the machine is obtaining, equates to a very precise value, which then is used for your purposes for evaluating the state of your sample. All of the results are displayed on a secure dashboard, and this is the same dashboard that you would schedule your remote testing. It's a very comprehensive dashboard. If anybody's interested afterwards, we'd love to go through a demo with you. And following each sample that's being tested is an automatic system cleanse. So we want to reduce any cross-contamination between samples. We don't want anything to be lingering from one sample that could give us a false positive in the next. So we just purge out the system and make sure that there's nothing present in the sample. We also don't want anything to grow inside the machine. So everything that we use is medical grade and has anti-fouling properties, just to really reduce any chances of growth within the machine. This is what the dashboard looks like. This component of the dashboard is where you would see your results, and it's all in real time. So you really don't have to wait very long in order to see what the result is. But this is a very typical qPCR graph. And it'll give you all the information about your sample in regards to the target that you're looking for. So your starting volume, what the concentration was, the CQ value, which is the point at where this line, like where the inflection point is. And at the end, it'll give you the number of copies for your target. There's another component that also shows the standard curve, all for due diligence. It's nothing needed on your end. So just to describe some of the previous deployments that we've done, there are a few very notable ones. Not necessarily all in beaches. A lot of these are in wastewater. But as I mentioned before, we do have many beach applications and recreational water applications, mainly to assess the hygiene of the water that could potentially be consumed, that could come in contact with people, that could make them sick, or it's not safe. But one very notable application is for biosurveillance. And we work very closely with the Public Health Agency of Canada. This is the CDC equivalent that we have here in Canada. And what they did, and this has been ongoing for a few years now, what they did is they would continuously send us samples from the National Microbiology Lab, and the same sample would go out to many different labs. We would evaluate it, provide our results that are provided by the Kraken machine. At the beginning, we were looking at targets such as COVID, peppermidal virus, which is a fecal indicator, and monkeypox. And now recently, we've included influenza A and influenza B into our platform, and also RSV-A and RSV-B as well. Another really important application is biosecurity. So we were at the Pearson International Airport for about 6 months. This is the busiest international airport in Canada. We were monitoring their wastewater from 3 different sites, from 2 of the terminals and 1 of the terturators. And we learned very quickly that the matrix itself, we learned all the variation that could happen in wastewater. We're very thankful that we started out in wastewater because it's arguably one of the most complicated matrices. Beach water is much easier to handle. But we learned a lot from this trial. There ended up being a very large difference between the terminal water and the terturator water. And from that point, we realized that we really need to customize all of the reagents that we're using for the specific matrix that's being tested. So not all matrices are made alike. There are PCR inhibitors that could exist. The sample may require different chelating reactions to happen just to prepare the sample more appropriately. So since that trial, we have taken a more active role in understanding the matrix very, very well. Sometimes we'll ask for an advanced sample just to make sure that the chemistry is very well understood. And at that point, we customize all of the reagents to make sure that it's going to work, exactly for your matrix for the targets that you're looking for. During this 6-month trial, we were looking at 3 variants of COVID. It was from the Omicron variant and monkeypox. And an important thing to note is halfway through the project, we noticed that one of the variants was kind of decreasing. So we made a decision at that point to just demonstrate the capability to pivot. And we developed a new target within, a new assay for a new target within just 3.5 weeks. So that basically concludes a lot of the capabilities of the machine. We couldn't do this without our supporters. We've worked very closely with many universities and institutions within Canada. And we're definitely looking to expand more into the global market. We do have 3 deployments in the States. So we're very familiar with international borders and how to get around those technicalities with logistics. And with that, I would just like to thank you all for your attention. And I'll be very happy to take any questions if there are any.
Thanks so much, Sarah. Yes, we're running ahead of schedule, so please feel free to unmute yourself and ask Sarah any questions you may have.
I'll share my email here as well in case there's anybody that, if you think of anything afterwards, I'd be really happy to discuss with you all.
Perfect.
Yeah, but in the meantime, if anybody has any questions now, I'd love to take them.
Yeah, and you can also find Sarah's email on the agenda as well as she just popped it into the chat. So
yeah, absolutely.
Perfect. Okay, well, not hearing any questions. Thank you so much again, Sarah, for your
Thank you.
presentation. We really appreciate you taking the time. And we're gonna take a quick 5-minute break before we come back for our final presentation. So why don't we reconvene at 10:45? Thanks, everyone. Okay, so our next presentation is going to be by Alan Marr from Orange County Healthcare Agency's Environmental Health Department, and he's going to be presenting on the Unified Monitoring Program they have to efficiently and effectively run their beach monitoring program. So, Alan, I'm going to make you a co-host right now so you can present any slides you want to.
It's good. Let me try that.
Go ahead.
Right. Let's see. Make that full screen. There we go. Can everyone see my screen just fine? Hear me well?
Yep, we can hear
Perfect.
Nancy.
All right. Good morning, everyone. My name is Alan Marr. As I was just introduced, I'm an EHS 3, Environmental Health Specialist 3, with Orange County Healthcare Agency's Water Quality Program here in Environmental Health. As she said, I am presenting on how our regional ocean water monitoring program was developed and how it operates with multi-agency involvement. So this is a little different from the previous presentations in that instead of looking forward into the future technologies and such, we're actually having a look back into how such a program was created and the considerations therein. A little background on our team. So for environmental health water quality, we are currently a team of 6 people. This includes a field sampler. Our water quality team handles many different programs, such as well development, liquid waste haulers, registration and such, cross connections, and of course our ocean water monitoring program. In addition to this ocean monitoring, I am in charge of collecting and preparing mussel samples for the biotoxin analysis in the state marine biotoxin monitoring program. So glad to help there. Mussel quarantine just began May 1st. So without much further ado, let's get started here. Let's see. There it goes. So a little background on Orange County in general. We have approximately 42 miles of open coastal shoreline, but in addition to this, we have some bays and harbors that we sample routinely as well. And these would be in Huntington Beach, Newport Beach, and Dana Point. There are harbors and bays in those areas. With our program, 4 separate agencies actually conduct bacteriological ocean water monitoring. These will be highlighted in a couple slides. As of 2023, all the agencies that are involved, we collected samples and performed analysis for about 23,000 analysis. But prior to this program being adopted, it was actually closer to like 50,000 analysis. So it's actually drastically been reduced since we adopted this program. I heard stories of samplers from different agencies passing each other on the same way to the same exact beach monitoring location in the past before this was adopted. So things like this kind of sparked that conversation about redundant or overlapping sampling. Obviously, we could use those resources in a better time and area. Regarding Orange County specifically, we actually fall into 2 different water quality regions. So this would be the Santa Ana region highlighted. Oh, I'm sorry, I didn't move the slide, did I? There we go. So we have the Santa Ana region, which is highlighted there in the yellow. And then we have the San Diego region 9 down here in the blue. So we actually have all the way down to San Clemente and a little bit further up to the borderline at San Onofre. Alrighty. So as mentioned before, the collaborative effort is between 4 different agencies, and these are the 4 different agencies that are involved. Orange County Healthcare Agency is my agency, obviously. So the water quality team here. Orange County Sanitation District is based in Huntington Beach, and they have an outfall at Huntington Beach proper. Orange County Public Works has different permits, MS4 permits and such. They do some monitoring, as well as South Orange County Wastewater Authority, or as we call them, SACWA. They're based down in Dana Point, so a little bit further south in Region 9. This is a quick breakdown of our sampling locations and kind of how these sampling agencies actually come into play here. So I'll go in a little more depth on this and how it was developed now that we have a firm background. So some issues to consider, there we go. Some issues to consider is when we're designing a work plan for all these agencies that are involved, we want to make sure that there's primary objectives. And when this was in development, this was back in December 2009 to 2010, early 2010. All those agencies that I mentioned before were involved, as well as other water board members actually of a subcommittee that was called the Monitoring and Reporting Subcommittee of the Southern Coastal Beach Water Quality Workgroup. So that was all involved in December 2009. So some of the things that were considered were kind of listed here. And as I mentioned, we want to make sure that any regulatory or public health monitoring areas are maintained. An example of this would be an NPDES permit or a critical swim area location, like an outfall location for NPDES, that is. As mentioned before, a elimination of redundant or overlapping stations was a goal also. We don't want those samplers giving high fives at the same location when that time and those resources can be better utilized with something more productive. When all is said and done, it was necessary to ensure that each agency was still meeting their primary objectives, whether it's for compliance or for public health reasons. So yeah, this work plan was then developed with that subcommittee and all the agencies. The group maintained individual or unique stations, say a public swim area or beach that meets all of the AB 411 monitoring requirements, or a local NPDES or MS4 permit location that is required for compliance reasons. Being able to sit down with the various agencies also highlighted that some stations were unnecessary for monitoring purposes. So a hypothetical of this would be a station that didn't meet any AB 411 requirements, and also none of the other agencies even needed to sample that for any of their compliance reasons. So with regard to stations that were in close proximity to each other, specifically we said 200 yards to each other, a study was performed on the previous 5 years data. So this study actually looked into the overall exceedance rate when compared to the state standards. A determination at that point was made. Again, this is back in 2009, 2010. But a determination was made to consolidate any two sampling stations, I'm sorry, that were 25 yards distance of one another, and they exhibit less than a 5% exceedance rate for all dry weather AB 411 single sample standards. So there was a full-on chart detailing the different agencies, monitoring locations, and we kind of compared those stations that were pretty much adjacent to each other or right on top of each other if they overlapped. Moving on. So getting some coordination between the agencies is sometimes, it requires some work. It can be a challenge at times, but this program was actually kind of developed in that light and getting those details sorted out ahead of time without further involvement. So the group, including the subcommittee, as mentioned before, for the Southern Coastal Beach Water Quality Work Group, set certain sampling frequencies for stations that meet the requirements for beach program. And we also wanted to make sure that all those NPDES permits were met and MS4 permits were being met, all those goals. Each participating agency with us collects data on specific days. So there's a set schedule. We already know when certain areas are going to be sampled and when the data is going to be available. One agency has to do this based on their workload and their demands and their staffing, they have to do it kind of on a weekly basis. It might change a little bit, but that's fine, because the communication really between all the agencies is very thorough. We're able to give each other a call on the phone or through emails. It's very, hey, we're going to sample this day. The data is going to be done this, or hey, we have an audit that day, so we're not going to do it Wednesday. We're going to do it Thursday, and so there's very open communication, and that's really needed for any agency coordination between 4 agencies for sure. So that's great to have. I'm very proud and happy to be working with all these agencies for sure. From that, there are different participating labs. So HCA, we have our own lab down in Newport Beach. Joe just spoke from earlier. And then we have Orange County San and SACWA. They both have their respective labs as well. Switching gears a little bit. So this is a slide I'm going to talk about our unified program. Now, this is a little different from the regional program in that this is only for Region 9, so that San Diego area that covers Laguna Beach and south of that down to like San Clemente. So each year, this particular program has an annual meeting. So we want to make sure that all those program goals that we set are being met, and that the program remains in optimal condition. Coincidentally, this meeting is actually next week. So I got a presentation ready to go to rock and roll for them as well. We share data. We have a presentation on all the data we collected, as well as any recent water boards reports or requirements. If there are issues for monitoring stations, like if our sampler can't reach it, if there's construction or any other kind of discussion, this is the time to do it at those meetings. Both government, such as city public works, marine lifeguard agencies, marine safety, and non-government stakeholders are present at these meetings. So I know that some people in the past from Gila Bay have been there. Glad to see they're on this meeting as well. And I think the Coastkeeper, Surfrider Foundation, all those have been at these meetings. So it's good to have everyone involved and on the same page. And that's what these meetings are done for. So specifically regarding the third-party data quality assurance. So obviously we want to make sure that our standards of data are the same throughout the program. So each of the participating labs, as I mentioned before, HCA, OCSAN, and SACWA have an active role in this program. There's thorough communication, and so we're able to make sure we're all on the same page with that. But all labs maintain their respective eLab certifications. So they have their own audits. And one of those recent changes was the method update rule in 2021. So that really pushed for the labs to revise their analysis methods. And Joe can provide some light on this in a minute, but we just wanted to make sure that everyone was following the same rules and analysis methods so that our data reflects those changes. Initially at each lab, as they're required to do, they perform quality assurance, so make sure that there's no issues with the data. And then when it gets to our agency via email, we get an Excel sheet and we actually maintain the database here in environmental health and do the reporting up to the beach program, so Beach Watch, for all the data that is collected through the region. The data that's not required by a beach program, such as those special studies that we might conduct that aren't for monitoring program at all, those are not published on our website. Now, you might ask, who performs the follow-up sampling? Well, for OCSAN, which is in Huntington Beach, they actually perform their own because of their NPDES permit. So if there's any exceedances at any of their sites specifically, they will let us know, hey, this was resampled, and we'll get you data on the next day. And they're very, very good about notifying us about that. There are a couple stations that they won't do rechecks at, And so that's when Orange County Healthcare Agency would come into play. Specifically, this picture is our sampler, Justin. So this was down in Laguna Beach. I was down there with them recently, but he's a valuable asset to our team. So always respect your sampler and make sure they're loved and respected. But all other samples, we might have to actually go into on-call or after-hour staff. We do maintain on-call staff 24/7 throughout the entire year. So someone might be working on Christmas, as we actually last year, for instance, we got a sewage spill that happened kind of over the Christmas holiday, unfortunately. So thank you to those staff that actually manned that position at the time. So with any reporting, we have various methods of actually getting the data out. Our website is there, OC Beach Info. We have a Twitter account. We have a mass email chain that we actually send out hotlines to, and that's that little ocean recreational update there. Press releases are more for sewage closures and things that are high profile like that. Of course, our Beach Watch website and our phone hotline. So you could call in and hear, for those that are visually impaired, you can actually hear those updates. This is kind of a snapshot of currently what our website looks like. We had recent concerns with accessibility, specifically how the two pins, green and yellow, were too similar in color in the past. So we changed up these colors to make sure that people who are red-green colorblind and such can actually see this a little easier. In addition to the color, we actually changed these sizings of the pins. So if there's just a black and white browser, then you could actually see that those are a little bit larger as well. On our website as well, we actually maintain historical data. I think this goes back to 2000, if I'm not mistaken. I'd have to double check that. But that can be accessed at the very bottom of our website, there where that little arrow is. And I try to send this out to Heal the Bay on a weekly basis, but that's another discussion. So benefits of the program. Well, clearly, if we're going to reduce our stations from like 50,000 analysis to 23, clearly there's cost savings there. There's a lot of redundant sampling locations in the past, and so that cleared up right away. That cleared up a lot of samples. In addition to that, though, there's a lower impact on each individual lab. So instead of our sampler Justin going out and actually sampling the entire coastline, he's able to then go collect follow-up samples. Since he's not sampling the entire coastline now, he's able to follow up on those exceedances that we have. And so there's a lot better turnarounds as well as resource usage. There's no real discrepancy in the data standards due to this program being generated and getting everything ironed out. All the standards are the same, so we can go with that. Challenges, as I mentioned before, coordination with multiple agencies or just multiple people in general can sometimes be a challenge. Scheduling conflicts might arise, as I mentioned. Let's say one lab has an audit and they can't get to the data till Friday, they'll report it. Well, that might push our rechecks back to a weekend. And so maybe after hours results would need to occur. So we'd need to coordinate all that staff and such. So requiring the initial startup, sitting down, doing all these analysis, studies and fine tuning, that requires a bit of time as well. All righty. So there's the easy button, right? Where should I start? So you would have to identify other agencies that are involved. Just a hypothetical here, there's Los Angeles County is here. Sounds like Los Angeles Sanitation District. So if they didn't already, I'm not sure on their program, but if they didn't already, they could coordinate and see where each of them sample respectively and kind of collaborate on those sampling locations and figure out, do we have any overlap, or are some really close proximity to each other, and then review the data at a chosen timeline, or maybe like a 5-year period or a 10-year period, depending on what you guys want, and outline a plan from there. I would advise similar concerns as public health and regulatory concerns still need to be met, whether you remove stations or not. You still have to sample some locations, and then finalize and possibly involve water boards agencies as well. Other than that, I believe that is my presentation, but if you have any questions, feel free to reach out. There's my email. It's also on the agenda, and happy to be here. Thanks, guys.
Thanks so much, Alan. Yes, we can take any questions. Please feel free to unmute yourself and or put it in the chat. All right, I'm not seeing any questions come up. Thanks again, Alan, so much for your presentation. It was super helpful. And like I said at the beginning of this meeting, we're going to be sending out a memo from the State Water Board regarding third-party data usage. So this will follow on Alan's coattails. Awesome. So with that, I'm just going to wrap up a couple of things before we sign off early. Our next meeting is going to be held in November of this year. A save the date and Zoom information will be sent out closer to time. Please use the link at the end of the agenda if you wish to subscribe to our emails. That's where the meeting information will be sent out from, as well as on our webpage. If you're interested in hearing anything about specific topics in future water quality work group meetings, please feel free to drop them in the chat or send me an email as you think of them. And with that, I will open it up to any questions before closing out our meeting. Okay, well, I hope you all have a lovely rest of your day, and thank you again for attending. Thank you again to all of the presenters who presented this morning, and I hope you all have a lovely rest of your day. Goodbye.
Bye. Thank you, Michelle.
Thank you.